Hello and welcome to another riveting video about section 3, and this is synthetic division and the remainder theorem. What we want to do is to use synthetic division to divide a polynomial by a linear factor, and we want to apply the remainder theorem. So what we know, we discovered in the last one, was using long division, okay? And that really, long division is another way of factoring. So let's write that down. That division, long division, is another way to factor. Okay? And so, what we've discovered was that it was a very tedious process to go through something like this, and it was just kind of a pain. But what I do want to note here real quick was that when you do this one step of division, what you end up finding is that if you take your dividend, which is x to the fourth minus x cubed minus 12x squared plus 9x plus 27, let me write that out here real quick, that x squared minus x cubed minus 12x squared plus 9x plus 27 is equivalent to me taking the quotient times the divisor, okay? So I would say that would be something like this, where I would go, all right, well, let me do x minus 3 times, what is that, x cubed plus 2x, x cubed plus 2x squared, 2x squared, there should be a squared there, that's a typo, plus 6x, or minus 6x, and then minus 9, okay? And that's the idea, is that I've factored out this x minus 3 from this big thing, and this should be x to the fourth, from this big polynomial, and then you're left with this as a result. And you can continue to factor that or do long division on that. So what I want to talk about is using synthetic division. Okay, which is another method on how to use division. And what I want to show you guys is that, we take our dividend, okay, and we take the coefficients. So I would take, if I just have x to the fourth, that's just a coefficient of 1. If I have negative x cubed, that's a coefficient of negative 1. If I have negative 12, that's a coefficient of negative 12, 9, 9, 27, 27. Now, the issue is coming up with this number here, the divisor. Okay, now when I take x minus 3, okay, that's a factor. If I wanted to find the value that is associated with that factor, remember, we have to set that equal to 0. We add 3, and so you get that x is equal to 3, and then that becomes this number here. Okay, so you have to take this divisor, set it equal to 0, and solve for x, and take that number, and that becomes your divisor. So this number is always opposite of what the factor says. So I'm going to write that as well, that this number, this 3, is opposite sign of the factor. Okay, so that's that. All right. So what I want to do here is show you guys how to do synthetic division. It's much easier than long division, and so I just want to go through that process with you. What I want to do here is I'm going to, first step is drop this 1 down underneath, okay? And so I'm going to do that, and then if I take 3 times 1, okay, that's going to give me a 3, okay? And then I add these two numbers together. So if I take negative 1 times 3, that's going to give me a positive 2, okay? Then I'm going to go back, I'm going to take 3, multiply it by 2, and that's going to give me a 6. I'm going to put a 6 right here. So then I'm going to add 6 to that, okay? So I'm going to take negative 12 plus 6, and that's going to give me negative 6, okay? And then I'm going to take 3 times negative 6, which gives me negative 18, okay? And if I take negative 18 and add it to 9, that's going to give me, what is that, negative 9? And then I'm going to take 3 times negative 9, and that's going to give me negative 27. Okay, and now when I add 27 to negative 27, all right, and I'm just going to add these together, put the addition sign there. If I add 27 to negative 27, that's going to give me a 0, okay? And the 0, this number here, was our remainder. Okay? So now, you got to think about, okay, what are we left with? What's the point of that? Well, maybe you notice something about these numbers and this polynomial. Notice how I have a 1 here, and I have a 1 as my coefficient. Notice how I have a 2 here, and 2 is my coefficient. Notice how I have a negative 6 here, and negative 6 is my coefficient. Okay, notice how I have a negative 9 here, and negative 9 is my constant. Okay, so when you do synthetic division, what that does is it actually puts this into a polynomial, okay? And you have to remember what you started with. Remember, you started with something that was x to the 4th, all right? And when you divided that, you got something x cubed. So this translates into x cubed plus 2x squared minus 6x minus 9, okay, as your quotient, all right? And obviously we can do the same thing and write it the same way, and we will write it this way when we factor these things. But this is just another way, we said that, long division is another way to factor, okay? But we found out that it was really tedious and it was a lot of signs and it was a lot of work, or we can do synthetic division, okay? So I'm going to write this up here, long division and synthetic division, okay, and synthetic division is another way to factor, okay, and that's all we're doing. All right, so let's move on. Okay, let's do synthetic division with a remainder, all right, and so what I want to do is I want to divide this polynomial here by x plus 4. So now remember what we do. We take the coefficients, and let me do this. Make our box like that. I'm going to put a 4 here, I'm going to put 18, I'm going to put 3, I'm going to put negative 18, and I'm going to put 9, okay? Now the question is what do I do with my divisor, okay? Now remember what we have to do. We have to take x plus 4, and we have to set it equal to 0, and then we subtract 4 from both sides, and so we get x is equal to negative 4, okay? So then we get negative 4 out here as our divisor. Okay, and what I'm going to do is I'm going to first drop down the 4. We always just drop down the first number, okay? So we get 4. So I take negative 4 times 4, and she's going to give me 16, okay, or negative 16, okay? And so then what I'm going to do is I'm going to add these together, all right? And so then 18 plus negative 16 is going to give me positive 2, okay? And then I'm going to take negative 4 times 2, and that's going to give me negative 8, okay? And so then if I take 3 plus negative 8, that's going to give me negative 5. Now if I multiply negative 4 by negative 5, that's going to give me positive 20, all right? Now when I add negative 18 and positive 20, that's going to give me a positive 2, okay? And then I'm going to multiply negative 4 times 2, and that's going to give me a negative 8, okay? And so we end up getting a remainder here, all right? So if I take 9 plus negative 8, that's going to give me 1, all right? And so this is my remainder, all right? Now let's remember what we're doing here, okay? What we're doing is we're trying to, number one, we're trying to divide this polynomial by this factor. Okay, so what I'm going to do is this. I'm going to write out that 4x to the 4th plus 18x cubed plus 3x squared minus 18x plus 9 is equal to x plus 4 times my quotient, okay? And so my quotient is 4x cubed plus 2x squared minus 5x plus 2. But then the question is what do we do with the remainder? Okay, the remainder is this 1, and here's what we have to do. We take our remainder, I'm going to add my remainder that's being divided by our divisor, which was x plus 4, which is this value here, becomes this down here. Okay, so when you have a remainder, that's what we have to do, okay? And actually, this whole thing is being divided, or is being multiplied by x plus 4 here, okay? And that's what's going to give us our polynomial here. So, okay, so there's that. Let's go on to the next page. All right, so let's talk about the remainder theorem. The remainder theorem states that if a polynomial f of x is divided by a linear factor x minus k, then the remainder is f of k, okay? So I want you to take a look at this one, okay? We're going to divide this giant polynomial by x minus 1. And so what we found was that if we take x minus 1, set it equal to 0, we get x is equal to 1, okay? And that's how I get this number here. That's how I get my divisor, okay? It's really important that we remember that. All right, so let's go ahead and do synthetic division here. I'm going to drop down to 2. Okay, I'm going to take 1 times 2, which gives me a positive 2, all right? And then I'm going to add those together. So I take negative 7 plus 2, and that's going to give me negative 5, okay? So then if I take 1 times negative 5, that's going to give me negative 5, okay? And if I take negative 11 times negative 5, that's going to give me negative 16, all right? So now if I do 1 times negative 16, that's going to give me a negative 16, okay? And then what I'm going to do is I'm going to add these together, and this is going to give me negative 23, okay? And this value is my remainder. Okay, now what I want to do is I want to plug in 1 into this function and see what we get, okay? So I'm going to do f of 1, okay, so wherever I had an x, I'm going to plug in 1. So 2 times 1 cubed minus 7 times 1 squared minus 11 times 1 minus 6, okay? And so now let's evaluate that. I'm going to do 1 cubed, which is just 1, so I'm going to get 2 minus a 7 minus an 11, and then minus 6. Yikes. All right, so now I've got 2 minus 7, which is going to give me negative 5. So negative 5 minus 11 minus 6 is going to give me negative 16 minus 6, which gives me negative 23. Oh, wait. Oh, wait. Oh, wait. That's the same thing as the remainder. You kidding me? Dan! Dan! Is Dan gone? Dan might be gone. Okay. Well, it's later in the evening. I think he has basketball practice. But Dan! Ah. Jim's in Mexico. Dan's at basketball practice. I'm just stuck here at school. I don't know. Whatever. Okay. So now, you get the same thing. So whatever your remainder is, okay, we're going to, that's the same thing as plugging in that value, okay? And the reason why this is important is because when I go through this, and if I wanted to say, okay, well, what's my remainder here, okay? If I get a remainder of 0, if I divide out this polynomial and I get a remainder of 0, okay, then what happens is that we get a root. We find out that 3 is a solution to the polynomial, okay? And when I say a solution to the polynomial, okay, that means that that's where the graph crosses the x-axis. That's where the graph crosses the x-axis. So we're really concerned about getting remainders of 0. Okay, that means that those divide evenly. That means that we won't have that these polynomials factor out evenly. Okay, and that's the idea. Okay, so that if you plug in 3, you do the synthetic division, you find out that it's 0. That's proof that if you plug in 3 into that function, that you're going to get 0 as a result. Okay. And when you have a y value of 0, okay, so here's what you got to understand. All right, let's zoom in here real quick. When you say that f of 3 is equal to 0, okay, that means that you have the point 3 comma 0. All right, and if you graph that point, all right, 1, 2, 3, here's that point 0. Okay, this is an x-intercept. Okay, x-intercept. All right, so now let's go ahead and let's take a look at this. And it says remainder theorem and factoring. So it says given that f of 2 is equal to 0, okay, and what that means is that x equals 2 is a solution, okay, to the polynomial, meaning that it crosses it means that f of x crosses the x-axis at x equals 2, okay? And that's all it's saying, okay? So what we want to do is we want to factor this, okay? And this is the start, okay? This gives us a clue that says, oh, x equals 2, that's a solution here. So let's go ahead and do that real quick. And what I want to do is write up my coefficients. Let's make my box here. And so I'm going to say that this is going to be a 1, a -2, a -9, and a +18, okay? And that 2 is my divisor, all right? So I'm going to drop down the 1, okay, and that's going to give me a 1. So I'm going to take 2 times 1, which gives me a +2, okay? And then if I take -2 plus 2, okay, that's going to give me a 0, all right? So now I'm going to take 2 times 0, which gives me a -9, okay? I'm sorry. Not -9, it just gives me 0. So that gives me a 0. And so if I take -9 plus 0, all right, that's going to give me a -9. So then if I take 2 times -9, that's going to give me -18. All right, and if I take 18 times plus -18, okay, that's going to give me 0, and this is my remainder, okay? So now let's think about what we had, okay? Our function f of x, all right, I'm going to write this down here. Okay, f of x is equal to x cubed minus 2x squared minus 9x plus 18, okay? Now what I've done is we've factored this. Now when I have 2 as my divisor, as a factor, okay, x equals 2, that means I'm going to subtract 2 from both sides, okay? And I'm going to get x minus 2 as a factor. So this can be rewritten like this. I'm going to say, well, I factored out an x minus 2, and then I'm left with this, okay? This coefficient here gives me a 1x squared, so just an x squared, and then plus 0x, and then minus 9. All right, so if I rewrite this, then I've really just factored this out to x minus 2 times x squared minus 9. Uh-oh. Do we notice what this is? Difference of squares, what? Okay, so now if I take this, all right, I realize that x squared minus 9 is the same thing as me saying x minus 2 times x squared minus 3 squared. Okay, and when you get a polynomial like that, that's just going to give me x minus 2 times x minus 3 times x plus 3. Okay, and now this is factored completely. Okay, this is factored completely. All right, and that's our goal, is to just be able to factor this. So once you do synthetic division, that gets you down, then once you do that and you get down to a quadratic, you guys know how to factor quadratics, okay? But you have to use synthetic division when you have a polynomial that's like 3 or greater, because otherwise, I don't know how to do it. Kind of a hard thing to do, personally. Okay, so once you have that factored completely, what's the point? Like, why are we doing this? And the point is that once you do this, you can solve this and find the x-intercepts, okay? And so if you take x minus 2, set it equal to 0, take x minus 3, set it equal to 0, and x plus 3, and set it equal to 0, then you find that you get x equals 2, x equals 3, and x equals -3. Now, if we look at this, now I'm going to graph this original polynomial, and I want to see where this graph crosses the x-axis. And I'll bet you $100 that it's going to be at 2, at 3, and -3. Okay, now here's the graph, all right, here. And what did I say? I said -3, look, you got -3. I said 3, look, you got 3. I said 2, look, you get 2. So there is a point to this, okay? And we did that using quadratics, but now we have to extend this out into polynomials, which I think is really, 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 really fun, okay? So yeah, there's that. And that's all I got. So I hope you guys, enjoy this lesson and you understand the concept of at least how to do synthetic division. It is a tedious process, but it will pay off in the end. That, my friends, is a guarantee. See ya. Bye.